Hello and welcome to the Deep Learning Approach to Network Anomaly Detection. I'm Renee, and Jamia was in charge of doing the related works for a lot of these models. What is our problem is we're trying to detect anomalies before they hit the major companies, like for example, what happened to GitHub. The way that we're going about it is we're comparing 5 different deep learning models, and we want to compare them for the most robustness in all types of situations. These are some of the mitigation steps for all types of attacks, including DDoS. The major step is detection, and that's where we're at. Some of the related works included a CNN plus LSTM model, and the reason we chose it was because we thought that the memory aspect would be more important, but as we come to find out, the autoencoder had more incentives. We used the KDD cup for the bigger number of features compared to NSL. And finally, the full list of features that we trained on was these 42. The architecture. One of the architectures that we did not use was the RNN attention model because it was bad at extracting features and it was too complex. Therefore, it allowed the CNN plus LSTM models to come in because the CNN parts would extract the features and the LSTM would remember the past packets and therefore deal with them accordingly. The fine-tune added an extra layer in the CNN for better feature extraction, but also reduce the kernel sizes to maintain that same performance. The CNN plus autoencoder, which turned out to be our best, had the same feature extraction, but it also alleviated the pressures of paying attention to the benign traffic from the predictions. Finally, the proposed CNN and autoencoder model, which was one of the most robust, we added one more convolutional layer and a smaller code layer. That way, it's able to rebuild the image of a packet from less parameters. What are the results? For small epochs, it turned out that the proposed autoencoder had the most harmony, accuracy, and the fastest time. So if a company is in need to release a detector really fast, that would be the best option. But we found that the more you train it, it's still as accurate, but there is another model that performs better, and that would be the autoencoder from the related works. It is slower, however. Some of the limitations that we faced were overfitting and the inability to detect new attacks, but that's where the robust fine-tuned model would be fast enough to be deployed quickly and then be trained on new attacks and be implemented right away. So in conclusion, the most robust model was the CNN and autoencoder that was fine-tuned, but depending on the type of deployment you want to do, you might want to go for the related works, which has more parameters at the code layer. We would love to show you the application of this model in real life during C-Day. So please stay tuned for that. Thank you.